Some of you are probably very comfortable with spreadsheets. I'm going to guess that all of you have used Microsoft Excel or Google Sheets, a decent number of times. I'm guessing. I don't know this as fact. However, not everybody learns really what the big picture ideas are. Not everybody learns the features that are all what I would consider core features of a spreadsheet program. So today and our workshop next time are really meant to kind of set a baseline understanding that everybody will share about what spreadsheets can do, the values that they have, the features that they have that are most useful to us every day, so that from here on, you can say you learned spreadsheets. But we're going to take a case study. We're going to look at a particular data set and see how you'd manipulate it in a spreadsheet. A spreadsheet program thinks about data in terms of rows and columns. So there are some common spreadsheet programs: Microsoft Excel, Apple Numbers, Google Sheets. There's LibreOffice Calc. These are the most common spreadsheet programs. Anyways, this is a screenshot from Apple Numbers, but it could easily be from almost identical to what you'd see in Google Sheets or Microsoft Excel. So rows and columns, in this case, rows going horizontally, columns going vertically. And notice that the columns have headings usually that explain what's in that column. So this is the coronavirus statistics by US counties. And on a certain date in Snohomish, Washington, there were one case of coronavirus. Each row and column has a unique identifier. By this, I'm not meaning the headings of the column, which are actually in a row of the data. What I mean are the indices up here. So A, B, C, D, E, F, and so on for the columns, and 1, 2, 3, 4, and so on for the rows. One point about a spreadsheet is that these are not associated with the data. So what I mean by that is, if I insert a new row, let's say between rows 2 and 3, the number of row 3 will now be changed to a 4 because there's going to be a new row 3 put in between them. What I mean by that is that you cannot count on the fact that this row right here will always be number 3. That might shift as you add in new data, manipulate your data. These numbers are not attached to the data. They're just attached to the spreadsheet program. Doesn't matter to the spreadsheet program what you put in row 3. It has no special attachment to this particular set of data. So again, if I inserted a new row in between 2 and 3, that new row would become the new number 3. And the old number 3 and the old number 4 would be shifted one higher in their index numbers. Same with columns. If I added a new column between A and B, what used to be column B would now be called column C. What used to be column C would now be called column D, and everything would be shifted over, right? So there's no attachment of these indices to the actual data. It's just about convenience within the spreadsheet program itself. All right, so just terminology-wise, at the intersection of any column and row index, you have a data cell. So right here, Snohomish is the value in a particular data cell. The values that you see in data cells are either manually input, meaning you can go and type in 1, or you can write a bit of code that automatically, formulaically calculates a value that is then placed in, right? So spreadsheets allow those two kinds of data input: manual input, where you type in the data, or programmatic input, where you write a formula and it then calculates some value and plugs it into that spot. And we'll be looking at those two things in detail. Within a cell, you can formulaically calculate a value that gets placed into any given cell. And this is an example of how you do that. You'd click into that cell and you'd start typing a formula. In this case, a sum formula that will add up the values that I have highlighted here. So sum, and I'm giving it as the arguments from E2 to E4 inclusive, and it will sum up the values in there. So when you want to enter in, and we'll actually play with a spreadsheet in a second, but when you want to enter in a formula, you just start typing with an equal sign. And now you're in formula mode where you can write the code that calculates the value that goes into the cell that you're writing into. There is an integrated development environment in any of the major spreadsheet programs. What we mean is that you have a code editor, usually built in. There are code editors that are not built into the spreadsheet, but that can be used kind of in addition to the spreadsheet. But anyway, you can write code in a code editor that is able to access the data in a spreadsheet, manipulate that data, overwrite that data, insert new data. So you can just write programs like you're used to doing, but instead of writing to text files and so on, can be accessing, reading, and writing within the spreadsheet itself. The screenshot here is just some code I wrote in Google Sheets. Google Sheets has a code editor where you can, online on the web, write some JavaScript code. Gets the active spreadsheet, gets some values, and here I'm looping through all the values and just printing them out. Which spreadsheets have which IDEs? Just to give you some terminology, just the words that you might hear. Microsoft Excel, you program your code that taps into Excel sheets in a language called Visual Basic. Microsoft has been, using Visual Basic internally for its Office suite for many, many, many years. And so Microsoft Excel comes with the Visual Basic for Applications editor. In other words, the IDE, the code editor you'd use to write programs that tap into the data in a spreadsheet. If you have Excel, pop open the developer menu and you'll see the editor option there. You may not by default see a developer menu option, so you can go in your preferences, I think, and you have to turn on developer mode, I believe, in some cases, in some versions. So if you don't see it and you have Excel, make sure you've turned on developer mode. Google Sheets, if you go to the Tools Script Editor menu, you will see your code editor there, and you write that in JavaScript. Apple Numbers, for those of you who use that, you don't in this case have a built-in IDE, so within Apple Numbers, there isn't your code editing environment. But Apple comes with a general program. All Macs come with a program called Script Editor, and you can pop that open. It's already on your Mac, and write in a language called AppleScript. This is Apple's automation language. Apple allows you to write scripts, programs, little programs that tap into what's happening in any of the Apple programs. Mail, Numbers, Pages, whatever the Apple programs are that they make. They always give you an ability to write code that then automates some of the things you do in those programs. That language is called AppleScript. So it's its own unique little Apple language. All right, if you are an open source enthusiast, you might be using LibreOffice instead of Microsoft Office or Google spyware. And so in there you have editors available within the Tools Customize menu. So you can customize many features of what's happening in your data by writing programs. So there are actually several different editor windows that can be popped open from this particular menu. Unlike the others, in LibreOffice, you can write in a variety of different languages. You can write in JavaScript and Python in their own LibreOffice version of the basic programming language. And Bean Shell, which I've never heard of until I looked this up, is some kind of a programming language, apparently, that you can write your programs in. Each sheet in a spreadsheet holds data about a single entity. An entity is a thing, a kind of a thing that you want to store data about. So if I was making a database or a spreadsheet that contains student information, my entity about which I'm storing information would be student. Each record or each row in my spreadsheet would be about one student. So student would be the entity about which I'm storing data. Each row in a spreadsheet is what we call a record, just a more general term that we use in database terminology. The entity that I'm storing is information about students. So my entity is student, singular. And each record would be one row in a spreadsheet or one row in a database about one student. So I'd have multiple rows for all the students in a class. Each record, so each one of those rows has a fixed set of fields. So a fixed set of columns that you have data in the data cells at the intersection of the row and those columns. And there's a fixed schema, right? You have certain columns with certain headings, and those are fixed. Every row has the same columns, the same fields. Each field is one attribute of the record. So if it's a student record, I might have first name, last name, email address, right? These are discrete values in specific fields. So first name, last name, email, I don't know, what else do I have about you? Your performance and grade-wise. I have your phone numbers also. So I have bits of data in different fields about each student. The collection of records, the one collection of records about one entity is called a table. And as we just said, the records are in rows and the fields are in columns. This is true of both spreadsheets and databases, as we'll see a week from now. Automated functions allow you to filter the data and perform analysis. So what can we do? First thing we need to do very often, which we'll see is just like any other kind of data analysis, is data munging. So you still have to do data munging. And here are some common tasks, some of which are spreadsheet specific, some of which are just general. The term spreadsheet and sheet are sometimes confusing. I'll pop open a spreadsheet program in a second and we'll look at it. But the spreadsheet could be considered the entire document, but actually there might be many sheets within a given document. So those tabs at the bottom of the spreadsheet program are different sheets. So spreadsheet, sheet, used interchangeably, but often the term spreadsheet is used to represent the entire collection of sheets. We have to just be specific about what we mean when we use the word spreadsheet. Are we meaning a single sheet or an entire collection of sheets in a single file? You should, of course, have headings at the top of your columns to indicate what they represent. Nice thing to do. Easy to understand headings at the top. So like CSV files have optionally the first row having headings. Spreadsheets almost always have actual headings. It's not really optional. Of course, you can delete them, but your data would become sort of difficult to understand if you deleted them. So put in headings at the top of each column of a spreadsheet. Often you have data that's merged or combined. So for example, if I had information about students and I had a spreadsheet where I had name as the first column, email address as the second, phone number as the third, grade as the fourth, name might have a combination of first name and last name. So it might be first name space last name, or it might be first name comma last name, or last name comma first name. My point being, it often is the case in a spreadsheet or in any data set that one single cell might actually have more than one piece of data. So in that case, I'd have in one cell both a student's first name and their last name. And I might want to split that up. Let's say it's written as first name space last name, but I wanted to sort by last name alphabetically. Well, I can't easily do that if the last name is put in that same cell with the first name before it, because if I do an alphabetic sort, it'll sort by the first name. So it becomes difficult to do analysis, to do manipulation of the data, if more than one value is actually merged together into a single field. So very often when we're putting data into spreadsheets, and same with databases, we will want to split up any fields that contain more than one value into multiple columns. That might mean inserting new columns into an existing data set. Often, if you're doing numeric analysis or textual analysis, your spreadsheet has certain features, just like Python has certain features for strings that are different from the features it has for ints and floats. Your spreadsheet's the same way. There are certain data types associated with certain cells, and you just want to make sure the proper data type is associated with the proper column. So if I have a column of names, well, just make sure that's thought of as being string data by the program. If I have numeric grades in a different column, make sure the spreadsheet knows that that data is a set of numbers. So you can associate data types to specific columns, which makes your analysis easier to do. All right, so let's get into an example. We're going to look at joy and upon joy, the number of COVID-19 cases. So we're going to be looking at data published by the New York Times, which comes in a CSV form. Not surprisingly, it's a super common way of publishing data because it's easy to parse into programs. The data we'll look at has date in the first field, county, the name of the county in the second, the state that that's in, FIPS, which is this number here, 53061, 53061. I'll tell you what that is in a second. The number of cases that day in that county. So in Snohomish, Washington on January 21st, 2020, there was one case. On January 22nd, there was one case. Right? So that's the way the data is structured. One day, one county, number of cases, and number of deaths. They're aggregating this data from many different sources. State sources, local county sources. They're collecting from wherever they can this data. And they've done a very good job of organizing it, making it consistent, filling in empty spots with clear averages or blank spots with notes saying that they didn't have the data for certain things. So they've munged the data, in other words. They've actually munged it significantly. And they've collected it and munged it and made it available to the public. If you're wondering what FIPS is, it stands for the Federal Information Processing Service, something like that. It's a federal number. There's a unique number for each county in the U.S. According to this system called the FIPS system. So that's what this field here is, and that's what these 53061s are, and the 17031. Those are the unique identifiers of that county in the U.S. It's quite long. I think it's over 1 million records at this point. And every day they're adding in for that day. So here's, February 8th. Here's February 8th, all the different counties in the U.S. And how many cases they had and how many deaths they had. That's this whole file. It goes all the way up to yesterday. So that's the data set. It's every single day since the beginning of the pandemic. Every single county in the U.S. on each day and how many cases and deaths there were in that place. So this particular data set contains, over 1 million records. And so the first thing you're going to realize, if you try and save that, let me just go and save that file. I'll go File, Save Page As. Let's put it somewhere I can easily get to it, like the desktop, uscounties.csv. I'll replace the version I already have from yesterday. And the first thing you'll notice, a problem. I'm going to double click it because I want to show you something about this data. First of all, it's taking a very long time to open up. Second of all, my computer's processor is churning like crazy. I don't know if you can hear the fan, but my fan is blowing on my computer like crazy. And when this actually opens, if it opens, I think I'm going to get an error message from Apple Numbers saying that it couldn't handle the number of rows in this file. So the first thing we immediately see upon trying to open up this file is, with large data sets, spreadsheets have problems. Sometimes they don't work at all. So we're going to see, I hope it works on Apple Numbers, but it certainly wouldn't work in Google Sheets. If I tried to upload this file to Google Sheets, which is a web-based spreadsheet program, it won't allow me, or it'll just crash. It can't handle this amount of data. A web browser cannot handle this amount of data. And Google Sheets is running within the web browser, and so can't handle this amount of data. That'll change in the future as programs get more capable, as also computers get more capable with memory and processing. But at today, around 1 million rows seems to be where these programs do not work at all. So native apps have an advantage in this case. With a file like this that's really large, you're going to want to open it up in a native desktop application. So this spreadsheet may look different. Your data has 1,034,000 rows. Numbers cannot support more than 1 million rows. Some content was not imported. So my data is now bunk. I can't do analysis like I'd like to do because they've chopped off some of the rows, right? So forget it, close it. This is a useless program. Get rid of it. We want to be able to analyze this data, yet this is too big for Apple numbers. So let me try Excel. Different memory allocations for different programs. Their designers have given them slightly different optimizations. Turns out from what I just tried on a Mac that Excel was better than Apple numbers, sadly for Apple. But I think this will work. All right, there we go. Possible data loss. Some features might be lost if you save this workbook in CSV format. Okay, that's fine. So they're just telling you that the native format of Excel is XSLX. That's the data format. You save files with a .xlsx extension. If I save in CSV, formulas and things like that I might do that are spreadsheet specific will not get recorded into the file. So you do want to save into a spreadsheet file format once you're working with spreadsheets. But you can import your CSV and then save it as a spreadsheet file format from there. Okay, so this seems to have worked. I've got the data imported. My processor and fan are still going crazy, but let's assume that my computer won't crash, and I'll do some analysis. So what we can see from this is that you have a nicely organized spreadsheet. I've got clear headings on the top up here. Remember, this is identification numbers for each county. I've got cases each day and deaths each day within each county, right? So that's the nature of this spreadsheet structure. Back to the point about sheets versus spreadsheets. This is the tab that indicates the current sheet I'm working in. I can have multiple sheets, which are really just new documents, by clicking that plus sign. So these are called sheets. All right, so in this sheet, I've got the data. And so we can take a look at it. There are 1,034,000 records all the way up to yesterday for each single county in the US. Now, what can we do? So first thing we can do is sort. If you wanted to sort the rows by, let's say, number of cases, you could do that in any of these programs. What I would do first is highlight the data I wanted to sort. So let me go back to the top. If you click on the column names, you actually just highlight the whole column. So let me just highlight everything. I'm holding down Shift and just clicking first and last. Data, sort by, and you pick which column you want to sort by. Let's say I'm going to sort by case numbers. You will then sort, let's do largest to smallest so we can stay at the top and see the highest numbers. And click OK. Not surprising, Los Angeles topping the list of recent dates that have high numbers of cases and deaths. So there you go, sort. You don't need to do anything magic there. You just click a menu option and you've sorted the data by a certain field. Where I really want to go with this is different statistics. So let me show you. I'm going to undo the sort, leave it in the sort by date mode, which it came in originally. And I'm going to go down to the very bottom. And at the very bottom, let's total up the deaths. Total, I'll write that word there. And here in this next neighboring cell, I'll type an equals sign. And that's going to trigger the ability to write a function or a formula. A formula is code you write in this cell that calculates the value that goes into this cell. So I'm going to write a formula. I'm going to use a built-in function that Excel and all the spreadsheets give us, which is sum. And I'm going to open parentheses and select this entire column from the very last row up to the top. I'm going to scroll to the top and grab that first row while holding down Shift so that the whole thing from very bottom to very top has been selected. So Shift is always the shortcut to from something you click on first till something you click on second, select the entire range between the two. And I'm going to close that parenthesis because it's a function call. And I'm now going to sum up from record 2 in the F column to record 1,034,032 in the F column and hit enter. And I hope it will at some point calculate what that value is. There we go. So the sum of all deaths in the deaths column is that 65 million? Yes, that's 65,006,000. All the deaths in the US from coronavirus. Does that sound right to you? Things are bad, but they're not that bad, as I understand it. So that is not right. So here's classic data science issue, right? So I've just outlined what I've written there. And then you give it the smell test. You've done some analysis. You've calculated something you believe to be a result that is of importance. And you want to give it the smell test. Is this right? Does this make sense? Does it seem to be the right number? So what I was able to find was that 65 million deaths in our data set that we just used are the total. Authoritative reports, and I'm linking here to Johns Hopkins University, which has become one, if not the foremost authority in these numbers. If you look at their stats somewhere, let me click on US. There we go, 487,109 deaths in the US, and they are the world authority at this point, at least the US authority on these numbers. So our conclusion is completely wrong. 65 million is not right, which is we've misunderstood the data. This is a classic problem, human error. We as data analysts didn't understand what actually was being published here. This is the cumulative. The data set that we've downloaded has every day for each county the number of deaths and cases, but that's cumulative, meaning the numbers for today or for yesterday, for example, are the cumulative number of cases since the beginning of the pandemic and the cumulative number of deaths since the beginning of the pandemic for each county. They're not the new ones. They're not the new cases and the new deaths for just that day. They are already the sum of all the previous days as well. So we didn't have to do a sum. If we wanted to find the actual answer to our question, which is how many deaths have there been total, all we would have to do is not sum all the rows, but just sum the rows for the most recent date. So the 15th is the most recent date. I'm going to scroll up till I find the top of the 15th records. From the very top of the 15th records, all right, from Autauga, Alabama, which I've never heard of before. That's the first day here, which is the 15th. And the data set is by default sorted by date. If I just highlight that record down to, or the deaths, let's say, from that record, all the way down to the most recent, the latest county, the last county, at the very bottom of our data set, then all I have to do is sum those up, and I'll get but let me just show you what I mean. So I'll go to that total cell where I wanted to output the total. Down here, I'm going to say sum equals sum to trigger the formulas of the spreadsheet, open parenthesis, highlight this cell, scroll up to where the 15th begins, the first line with the 15th in it, hold down shift, click that one, end the parentheses, hit enter, and boom. 486,148. Let's flip back to the research I did that showed us the numbers. 487,109. So much, much closer, right? So now we're in a range that, yes, we're passing the smell test. We're not exactly matching Johns Hopkins, but New York Times has, obviously slightly different way of counting this stuff, but it's pretty close. So we're getting close here. So something didn't smell good in the beginning. We've done something wrong, correctly identified. We actually have cumulative data for each county. So we've just had to do the sum of all the counties just for yesterday, and we get the overall cumulative count for the US since the start of the pandemic. Okay, so that's a very common problem, right? The data is right. It's just that your understanding of the data has been a bit off. So I did this yesterday, and the number was a little bit smaller. So we've made a series of assumptions about this data. And when you're doing this kind of analysis, you want to be aware of what your assumptions are. We've assumed that the raw data is reliable and trustworthy, right? That's the number one assumption, the most specious assumption in many cases. Is this good data? Can you be pretty sure that this data was collected in a coherent way and munged in a coherent way? In this case, it's been collected and munged by New York Times, pretty reputable, depending upon who you follow on Twitter, pretty reputable. And I believe that they have a pretty serious data science outfit working there at this point. They've embraced data analysis, as a lot of their journalistic reporting now includes that. I'd say it's a pretty reliable source. We also checked out Johns Hopkins, and our data matched more or less, very closely what they have. So it seems to be a pretty valid data set. We've also made an assumption, and this is maybe not obvious, but we've made an assumption that no deaths are counted simultaneously in 2 or more different US counties. I don't know how reporting of deaths works. This is something that probably varies by state and by region. But could it be possible that one death could be reported in 2 different counties? Maybe a person resided in one county but went to a hospital and died in a different county. Are we sure that that's not going to be reported twice? I don't think we should be sure about anything, right? So these are all questions. And the question is, how much do we think that impacts or that possibly impacts our data? So I don't have the answer to that, but that's a question. It's an assumption we've made that one death is reported in one place. May not be true everywhere. We've also assumed that the data set includes one record for every US county on each day. So when I went and just summed up the numbers for yesterday, I assume that that represents the entire US. I haven't gone in and checked that every single county in the US is present in this data, but I'm assuming it is. I could be wrong. We can check that. That's something we could check, but would take a very long time. We've also assumed when it comes to case counts and so on, I didn't add this here, but when it comes to just the case counts, there's kind of an implicit assumption that we're assuming a person can only get COVID and be diagnosed with it once. What if the same person is being diagnosed twice? That certainly could be possible. And would that impact the analysis that we can do with this data? Yeah, if we're using the case counts to indicate how many people had corona, that would not be accurate if the same person could potentially get corona twice and be diagnosed twice and counted as 2 separate cases. So we have to be very well aware of what these numbers mean. As I understand it, they mean diagnosed cases. So it's possible some people are getting diagnosed positively twice. How many? There's no way I can know that. So again, it comes down to the reliability and trustworthiness of this data set. And maybe New York Times has written up some of these assumptions into their documentation of this data set, which I haven't thoroughly reviewed. But that might be something to look, how many cases do we think are duplicates, the same person counted twice or 3 times? All right, so how can we check these things? Well, they're not all really realistically checkable by us. So again, it's better to rely upon reputable sources that we think have done some of the legwork, the research work for us, because some of these things are virtually impossible to check, like whether or not a case can be counted twice or a death can be counted twice. These things, we don't really have any real way of checking. We can maybe make estimates, best guess estimates at how many cases are counted twice, how many deaths are counted twice, but these are really just guesses. We wouldn't have any real data on this. All right, so that's the first set of analysis, just simple statistics. You can come up with the sums, the averages, the minimum and the maximums, and these would all work the same way. If you wanted to find this county or the number of minimum, you just do a min function call. And that would show you the lowest number in the set of counties that have COVID. What is the lowest number of any county? Well, apparently there are some counties with 0. What's the max county? You can replace the sum up here with max. So there are a variety of statistical functions, min, max, average, sum, that all work the same way. You give it a set of data points to do some statistic on, and it will go and do what you say. If I do a count, that would mean how many records are there? So 3,168 records for yesterday. How many counties are there in the US? I don't know the answer to that. But New York Times is counting 3,168 different counties in its data set for yesterday. We can check whether that's the right number. All right, so min, max, sum, average, they all work the same way. You just plug in equals and then the formula that you want to use, the function you want to use, give it the range of cells you want it to analyze, and it will spit out, when you hit enter, it'll spit out the result into that cell. We can impose criteria. So let's say we wanted to only track COVID cases in New York's Hudson Valley region. So what does that mean? Well, the Hudson Valley region, where I happen to live, is an area of New York north of the city, along the Hudson River, and there are counties on either side of the Hudson River that collectively are called the Hudson Valley. Now, what are the names of those counties? Well, you can look it up. There's plenty of information online about the names of the counties. So what we really would need to do, if I wanted to count COVID cases in the Hudson Valley, is essentially filter this data set so that we only count counties that have the name of one of the counties that's in the Hudson Valley, right? So we can do something like what we just did, where we sum it all up, but we don't want to sum up everything we want to only sum up those where the record has a name that is a Hudson Valley county. Right? So this is the problem here. We have a giant data set. We want to just sum up the records that have county name as one of the Hudson Valley counties. So that's the issue here. So I've made an online version of this spreadsheet you can click through to get to. Now, what I did is this is on the 14th, so 2 days ago. I did this yesterday. I've just chopped out that part of the data set that is for 2 days ago. That now is small enough that we can actually share it in a web-based spreadsheet. So one of the ways you can share data is just chop it up into smaller chunks. And so that's what I've done. Since these are cumulative numbers, we can get a sense for cases just by adding up for yesterday or the day before, and we don't need all the other records. So I've just chopped out the records for 2 days ago so we can just analyze the cumulative records up till 2 days ago. So what can I do to now figure out Hudson Valley COVID cases? All right, so what we can do is we can use the filtering abilities of these functions. So what I did, and I have a spreadsheet I've already made, which I'll flip to since I'm running low on time a little bit, but I've already made a spreadsheet where I've manually gone and looked up on Wikipedia what are the names of the counties in the Hudson Valley, and I've added additional fields with those names. We'll see this in a second in my online spreadsheet. And then I'm going to use a filtering ability to count from that large set of records the sum of only those records that match Putnam, the sum of only those records that county name is Rockland, the sum of only those records where the county name is Westchester. So I'm going to get a column here of subtotals for each one of these counties. All right, so again, I've manually, just by looking on Wikipedia, just added this extra column for the county names that are in the Hudson Valley. I also, and I'll jump to some of the later slides here, I've also figured out the population of each county. How did I do that? Again, just looking up online, reputable sources, census counts for the different counties. So I've actually got a sense of the population in each county. I've got the names of the county. And then I want to figure out how many cases are in each county. Again, I can't just do a simple sum of the cases here, because that would sum up everything in the whole country. But I need to use a filtering sum that not only sums, but also sums only those records that have county names that are Putnam, only those records that are county names Rockland, and so on. So how did I do that? I used the sum ifs. This is like sum, but provides the ability to do conditional statements. And every spreadsheet will give you kind of documentation on how this works. In Google Sheets, it kind of pops up this cheat sheet here. So first thing I have to give it is the range of values that I want it to sum up. In this case, I'm saying everything in column E. That's how you write everything in a certain column. I'm going to zoom in so you can see that more clearly. So E:E means everything in column E. So that just means the whole column E. If I did E1 to E10, that would mean only cells from 1 to 10 in column E. But just leaving EE, that means just the entire column. Remember, I chopped out this data set, so it's just the records from one day. And that's fine. I want to sum up all the counties in one day. And then I provide these conditions. I say here, criteria range 1. This is the column B I'm pointing to. So I'm saying, go look in column B. That's the column I want you to look at. And I want you to compare for any row what's in column B to what I have in H2. What do I have in H2? The word Putnam. That's one of the counties in the Hudson Valley. So I'm saying go into column B for any record, check whether it is the value in each record is the value Putnam, which I have as the next argument. And if it is, include it in the sum. So that's the ifs part here. I'm doing a conditional. I'm saying sum up the values in column E, but only if what's in column B for any record matches what's in H2, this column right here, this field data cell right here. And then also check whether what's in column C is New York, because it turned out, as I wrote some notes in the slides about this that I'm kind of skipping through to keep this going fast. What it turned out was if I didn't have that checking column C stuff, that's all fine. It's going to go through column E, add up all the numbers there for those records where what's in column B is Putnam. But it turns out that there might be the same county names in multiple states. So when I did this, I got a result that suggested to me that it wasn't right because I did the smell test. It didn't smell right. And I figured out that actually there are the same county names in different states. And so I needed to add this additional check, not just
checking the county name like I'm doing here, but also checking that this is in New York that we're talking about. And we do have the state in column C. So I'm saying include results where the county name is the county name Putnam, but also that the state name is New York. So that's the SUMIFS function. The SUMIFS function allows you to apply one or more criteria to your aggregate statistics. And that's what we've got here. So I've done that for every single of these counties, right? This is going to check Westchester and add up the numbers of results for Westchester. This is going to check Dutchess County and add those numbers up. So what we have here are the counts for every county. I didn't have to go through and cherry pick from these records which row is, Westchester, which row is Dutchess, which row is Putnam. I've just got my formula doing that for me automatically, scanning the entire column E, but only including those that match the indicated county names. It saves me a lot of time to write it in this way. I was then interested in what percentage of the population that might be. So I did look up the population counts on the census data. And I then just did some simple math to say, what is the percent then of those counts out of that population? So I live in Westchester County. We've got about 11% of the population has apparently had a case of COVID. There's an assumption built into that stat, which is I'm assuming that one person gets counted once in case counts. I'm assuming that one person isn't counted twice in terms of cases. That may not be a good assumption, but that's my assumption. My working assumption is that generally speaking, a single person is counted as one case, even if they're diagnosed twice. Again, not necessarily a good assumption, but maybe the error is a small error if there is any error. All right, so 11% where I live have been apparently since the beginning of the pandemic diagnosed. That's on the upper end, of course, in the Hudson Valley, except for Rockland, which is a little higher. All right, so we're in one of the highest danger regions in terms of COVID where I live. So you see, with a little bit of work, if you know what you're doing, you can come up with some interesting statistics, right? So I can take this giant data set and slice and dice it a little bit and start to break it up into different regions, different areas, as long as I can do some manual work, look up the county names of interest to me, look up their populations of interest in some other related data set, in this case, the census. Use the New York Times data set to get the case counts for each one of these counties, and then do some math to get the percent of the population that represents. So I can see that in total, because I've added up down here the sum of everything above, in total, where I live in this general region of the world, 250,000 people have had COVID already, out of a much larger number, right? So you've got 28 million, 29 million, and we only have 250,000 having COVID already. Or is it 2.8 million? Sorry, that's 2.8 million. All right, so generally speaking, my numbers looked okay when I did when I limited it to only counties that have those names in New York. My data set looked pretty good. At this point, we could start to think about what further kind of exploration could we do with this data, where what other kinds of analyses might be of interest to us. We know now that I can go in and kind of cherry pick different counties and add them up and get the regional clusters. But what about time series, right? The original data set had every single day since the beginning of the pandemic, every county and their stats. So you might start to think, well, maybe if I made a chart of kind of the growth in a certain county over time, that could be interesting to us. Or a map where we show hotspots, what areas have had the most since the beginning of the pandemic compared to what others have had. So there might be other kinds of insights we might want to generate into this data, because we know the data set has every day of the pandemic, every county, case counts, death counts. And there might be other things we can do with that data. So just some kind of brain thoughts here. We have cumulative set of cases since the pandemic began. We know we can count up certain kinds of counties pretty easily, and we can filter those to a certain date. If we wanted to show case counts over time for only the Hudson Valley, we could do some ifs, but not apply two criteria, which is that any record we want to count matches a certain county name and matches the state name New York. But we could actually use three criteria to come up with something interesting, which is matching a specified date, a specified county in the state of New York, right? So I could not just do on one day the stats for, let's say, where I live in Westchester County, but on every day since the beginning of the pandemic, add those things up. How might I do that? Well, that's going to require a bit of spreadsheet skill. The way I might start that, I won't finish that, I think, but the way I might start that would be something like, put the county of interest down here, and put the dates that you're interested in. So let's say 1/1/2020, 1, 2, 2020, and just keep a row like that going along. And then in each cell right here, I could say, go into this case counts column, match any record that has the county name Westchester and the state name New York, but also has a date match to the date that's right down below. So I can do something like sum ifs, the data range that I want to sum, in this case, the cases, comma, criteria I want to apply, the column where the criteria lives, in this case, the county. The criteria I want to apply, I want it to match Westchester, this county right here. And an additional criteria, another column I'm interested in, the state, I want it to match New York. And the third criteria that I'm doing, which is new here, I want the date to match, where's the date? Over here. I want that to match the date that's right down below, and close off that parenthesis. All right, so we've got nothing. But we can start to apply, additional criteria and get for every single day the case counts within Westchester, and then I can easily chart those. Let me just show you one other thing I've done, which is an example of a kind of a plot that you can do. And I've done an example here, which I'll skip to, and you can read through those slides later. But I've done what's called a pivot table, which I've explained in the slides what that is. And what I can do is I can group together related records. For example, I can group together all the records that have the same county name. That have the same state name. So that's what I've done here. I've created an additional bit of data here, which is called a pivot, which has all the records within Alabama grouped together, and then I can perform statistics on them. The sum of all cases and the sum of all deaths. Alaska, the sum of all cases, the sum of all deaths. So the pivot table, what it can do is group together all the records that share a common field value. And that's what I've done. I've said group all the records that share the state value Alabama, or actually just that share the same state value no matter what the state value is. And the pivot table will automatically then outline all the different values it found in that state column and perform the aggregate functions that we want it to perform on that entire group independently of other groups. The slides have a deeper explanation of pivot tables, but I wanted to give you guys the flavor of these things. And I've additionally thrown in a map here because, of course, once you have this data, it's easy enough to click a button and generate a map. And here's a map of the US with cumulative death counts in bubble form. So each state has a bubble that represents how many deaths have there been. Actually, I think that's how many cases have there been in that state. For some reason, the higher numbers are green and the lower numbers are red, and I couldn't figure out how to get that to be the right color coordination, even though I did my best. So anyway, the colors are a bit misleading, right? Green is really bad and red is good if it's small, but it should be in reverse, really. So anyway, so that gives you a flavor. I just clicked the button to do that. I highlighted the data set I had created with that pivot table. I did something like this. I then just clicked the button, insert chart, and boom, I got this chart created. It really took me almost no work at all.